This is the Weather Lounge here at WeatherWorks.
Hello, everyone, and thank you very much for joining us once again here in the Weather Lounge. I'm your host, meteorologist Brad Miller, and our podcast today comes to you from our WeatherWorks headquarters located in Hackettstown, New Jersey. And joining me, as always, is now my athletic co-host, meteorologist Mike Mahalik.
So what are you trying to say, Brad, about athletic?
Nothing.
You know I obviously haven't been working out that much.
I mean,
Are you insinuating something?
No, it's just, I was calling you all groovy words and things like that. I figured athletics. You played a lot of sports back in the day.
Oh, yeah, high school superstar, I guess.
Yeah, you peaked in high school just like me, huh?
Yeah, yeah. Did you ever see that thing on Facebook or whatever? It's like people who peaked in high school.
Yeah.
It's like funny memes and things like that. Speaking of people who peaked in high school, let's welcome in meteorologist Mike Priante to the program too.
All right, I'm about to leave this podcast.
Mike, have you graduated from high school yet?
Brad, I can
kidding.
make you silent this entire
only
podcast.
kidding.
I have the audio capabilities here.
Mike has graduated from college.
Turn off his channel.
I can. I have the buttons right here. I can do it right now,
No.
Brad. Are you sure?
No.
All
All
right.
right. No, apologize, and then we'll go through.
No, I can't do that.
All right, fine. Whatever. Go ahead, Mike. Let's introduce this topic
Yeah,
here.
hey, so, we did this once before on the podcast. We talked about weather terms you should know and things of that nature. And there's so many weather terms out there that people want to know about. I think it's time to kind of revisit that subject. And this time, I think we're going to skew more towards the winter.
Oh, that's true, too. There's a lot of weather terms out there. I mean, this may not be the final weather terms podcast. We could do a part 3.
We could have like 5 parts. I mean, if you take a
that's
look
true.
at the American Meteorological Society's glossary, there's like
that's
a
true.
ton of definitions we could totally go through, although a lot of them are probably a little bit too boring to talk
that's
about.
true. And plus, we're audio. We don't have any visual here, so it's kind of, we got to pick and choose what we can kind of explain.
Yeah,
but
we don't want to go through the AMS glossary because we want our visitors to, listen and come back.
But I do like the winter theme here today, Mike.
Absolutely.
We're in winter, and this is a perfect topic here, and we're gonna get going on it.
Yeah, and I think our special guest star over there, Mike Priante.
Yeah, apparently the person who hasn't graduated high school yet. Thanks,
Yeah.
Brad.
I meant
No.
because you're so young. That's the only reason I said that.
Well, I guess I'll take that as a compliment.
There you go.
No, he's obviously a Penn State graduate.
Yeah.
Of course. Just like myself.
Yeah, exactly. All right, well, let's start off. I'll start off here with, you guys know what a blizzard is?
Nope, never heard of it.
No?
Everybody knows what a blizzard is,
Well-
in a sense, but I think you're going to set us straight here because a lot of people think of blizzard. They're thinking of, driving snow and heavy winds and feet of snow. But that's not technically right, is it, Mike?
No, it's not.
It's what every weather enthusiast along the I-95 corridor wants every single week.
Exactly. So here's the official definition from the National Weather Service. Essentially, it's a severe snowstorm with strong winds and low visibility. Now, the criteria of that is sustained or frequent gusts of 35 miles per hour or greater. And for those that are metric friends out there, 56 kilometers per hour. I actually went in and did the conversion because I see where our listeners are coming from. There's some that are not in the U.S. So
I heard they're teaching that in high school now.
Yeah, I mean,
Metric
it's good.
system.
It's good that
Really?
we're actually teaching
don't
more
know.
about the metric system, but anyway, so that's kind of the wind aspect, but there's also a visibility aspect too. We have a prolonged period of less than, I believe, a quarter mile visibility or lower, and this has to be over about 3 or more hours. So, you usually got a big storm like that can perhaps be a little gusty, leave some blowing and drifting snow, but it has to be at least 3 hours for it to be technically a blizzard.
And a lot of times that's hard to achieve. You really don't understand how hard that is to achieve in a snowstorm.
It's very hard, to achieve that.
Because to meet those criteria with that amount of wind and that amount of visibility restriction over 3 consecutive hours, it's tough to do. But the funny thing about a blizzard is, Mike, it doesn't have to technically be snowing.
You're right, and I was going to get to that second part. So
I beat him to it. I ruined his thunder, Brad.
I know.
Well, hey, I got some more thunder later on.
That's
yeah,
terrible.
It's a little bit of a
Terrible
foreshadowing. So another thing that they consider, it's called a ground blizzard. And what that is essentially no precipitation's falling. But if you've noticed in a storm, sometimes you see, and this really happens a lot with like more fine powdery snow as much than like wet snow. But sometimes the winds could be at the criteria and the visibility is the criteria. But it's really the snow on the ground, on rooftops, cars. It looks like a blizzard outside. It technically is, but it's not falling from the sky. So in that instance, it's called a ground blizzard. So, yes.
I think that usually happens more in the plain states because a lot of times they get those big lows that really wrap up with the winds.
It does. Very flat areas. This happens a lot. And there's also one more thing. There's also a severe blizzard, apparently. It's kind of like, I guess if you were to compare it to like a hurricane, major hurricane, it's like the next tier of blizzard. Severe blizzard is when you have near zero visibility and when your winds are over 45 miles per hour, sustained or frequent gusts. So if it's a really bad blizzard out there, and you barely can see in front of your face, that's a severe blizzard. So another little tidbit there for you to.
Interesting. Never heard the severe
haven't
blizzard
either.
one either. That might be a new one.
Yeah, I don't know if it's used as much by the National Weather Service, but apparently that's a meteorological definition from the AMS. So whether or not they use that's up to their discretion. But anyway, I guess we'll go on to you, Mike, now about another weather phenomenon that happens a lot, especially here in the Northeast.
Yeah, so I want to talk a little bit about lake effect snow. And from low visibility and things like that, taking on lake effect snow is pretty much hand in hand here because, obviously you get very heavy snows coming off all the Great Lakes. Lake Ontario is especially noted in the Tug Hill Plateau, and Erie, can sometimes hit Buffalo very hard, and not Watertown, that's the Tug Hill. But also off of Lakes Michigan, Superior, and Huron, they all have their own lake effect snows. So I guess the big question is, how does this happen? How does lake effect snow develop?
Magic, right?
Magic?
Magic, yeah. That's how
I got
snow
magic
happens.
in one corner. Brad says what?
It kind of is because it develops like out of nowhere sometimes. It just it goes from clear to snowing in some areas.
So basically, what lake effect is in the most basic terms is that you have a relatively warm lake and you have very cold air blowing across that lake. So what happens is that cold air picks up the moisture from the lake and basically it saturates that air as it crosses. And then once it hits land, it gets a little bit of elevation as you get away from the lake level to the surrounding hills and stuff like that. And your precipitation will eventually condense, or I should say in this case, form snowflakes, not condense in that fact, and produce your snow. So that's essentially what's happened. So you need a very warmer than normal lake, or at least a relatively warmer lake. I think and cold air blowing over that.
Okay, so essentially that is magic, right?
Essentially magic.
Just scientific magic.
Scientific magic. It's like nature's snowmaking system, basically.
There we go.
The
There
thing
we
is,
go.
they set up in kind of rows too.
Right. And so that's the thing. These can set up in several different ways. So if you have a very long lake, like let's say, Erie or Ontario, and you have the wind blowing lengthwise across that lake, this will typically form into one solid band. And a lot of times this band is very heavy snow. I mean, we're talking 3-inch-an-hour rates, 4-inch-an-hour rates, even higher a lot of times in these single bands of snow that form.
Creating severe blizzard-like conditions.
That's correct, especially if you have enough wind. So yeah, I mean, there's the single band state that happens like that. But if you get the cold winds blowing perpendicular to the lake or across the width of the lake, a lot of times you'll get a multiple band situation where you have several different snow bands coming off the lake. It might be 4, 5, 6, however many that may show up. Now, typically those are, I'd say, a little bit less intense because the number of them, you don't have one single major band, you have multiple smaller bands. But yeah, I mean, that's the two different ways that kind of happens. And when that multiple band situation sets up, I don't know if you guys remember from school, but they were called cloud streets that develop, where you have rising air where the snow and clouds are developing and sinking air in between that band. And then you have another column of rising air and another column of sinking air. So that's why you have those streets, because there's different columns of rising and sinking air happening.
Okay. Well, there you go.
So, yeah, I mean, lake effect's a big one, but it doesn't always happen on lakes, right?
I was just going to say, ocean.
Yeah, it can happen off the ocean too.
Wow.
Now, if I had our listeners in here, I'd ask them, what do you think what type of band would come off the ocean? But this isn't a class, so I can't really ask them.
But, yeah, don't bore me, Mike.
Yes.
We're trying to learn something here.
Okay.
Fun.
Well,
this is the fun podcast. This isn't a
right.
I want to learn here.
All right, fine. Well, anyway, ocean effect can happen, and those occur in multiple bands the same way. A lot of times in Cape Cod.
Cape Cod's a big one.
It can happen on cold northeast wind. Certainly happens with the warm ocean temperature and the cold air above it.
Is the snow salty?
Is the snow salty?
I mean, if it's an ocean.
Well, it's not salty, but there can be salt in the air, in the atmosphere, that allows for that
nucleation.
Nucleation, thank you.
Reverse osmosis happens in the atmosphere, correct?
Not quite, I don't think. But anyway, so the nucleation happens on those salt grains, and actually it allows snow to develop at a little bit warmer temperature.
Ah.
Huh.
It's interesting.
We're defying the laws of physics here,
We
folks.
are, because usually snow growth is what? Negative 10 or?
Negative 10 to...
No, minus 12 to minus 19, 18.
I think you could get it at negative 10 too.
Yeah.
So
this is in Celsius, by the way, not Fahrenheit.
But a lot of times with a ocean effect type of situation, you might get it happening at minus 8.
Right.
Instead of minus 10 Celsius. So it's quite interesting how that happens.
It's the same principle in terms of also how like the freezing level and the melting level changes based on how you affect the liquid, essentially, right? So like, salt water freezes at a different temperature than regular fresh water. Same sort of process, except we're talking about like, nucleation and crystallization, which a different type of the water cycle, so to speak.
Right.
So,
but anyway, so ocean effect, though, still on the lower side of totals. It's that single band that comes off lakes that is the one that really hammers people. And I'm sure people in upstate New York, around Redfield, Watertown, those areas really know what I'm talking about when it comes to those single bands of snow coming off Lake Ontario.
I remember that one year in Buffalo, they got like 3 feet. It was an early season one too, like in November, but it was like a historic lake effect event there.
I mean, I think there's instances up around Redfield, New York, where they've had over 100 inches out of a lake effect event.
That's insane.
I mean, it's over the course of a couple of days.
Right.
But still, I mean, imagine getting 100 inches. I mean, what did we have last year in Hackstown? It was probably like 50 or some odd inches.
Probably.
For the whole season.
The entire year. And a lot of that came out of one big storm.
Right.
Where we got close to 30, I think.
Right. And also, remember that one year, I forgot what exactly it was in Boston, they got like 90 inches of snow over an entire season.
Yeah, that might have been Boston, but I mean, there were some areres that got close to 120.
Of course, but you think about that, that was the entire season over the course of like 3 to 5 months.
Yeah.
And you're talking that 100 inches can fall of snow in several days, if not, 48 to 72 hours. So, I mean, that's insane.
Yeah.
That's pretty insane.
I don't know what the hardest rate of snow that you guys ever saw was.
Oh, boy. I don't know. Maybe like about 3 inches an hour.
Right.
Probably.
Yeah.
So if you're going over that in this lake effect band, just think about how hard that's snowing.
You can't keep up.
The most that I've ever seen was 4 inches in an hour. And that was in a blizzard back in 2016.
Yeah, that was a more synoptic event.
And that was insane to me. I never saw it snow so hard in my life. And I could say that truthfully.
Yeah.
Unlike some people who might go out and see it snowing and be like, it's snowing as hard as it possibly ever could be.
Well, Mike, we'll talk about that. You're stealing my thunder
I'm
again
not
here.
stealing any thunder.
Yes, you are. That's one of my topics here. So let's we'll get to the whole criteria of the intensity of snow in a little bit. But I think afterwards, the next thing would be probably still you, right? It ties into lake effect, and sometimes lake effect bands do kind of get categorized as this, right?
Yeah, so what can happen is when you have lake effect bands, a lot of times you can get snow squalls breaking off the lake effect bands. Now, these are typically a real problem if they start crossing major highways, especially in areas of the Northeast. Like one that comes to mind is I-80, where you can get one of these snow squalls, and it's basically like a wintertime thunderstorm is basically what it is. And that visibility will drop quickly to a quarter mile or less in a snow squall, covering roads, reducing visibility, and that's how accidents happen very easily on interstates when these snow squalls develop. So that's one way you can get snow squalls. They come off of the lake effect bands. The other way might be an Arctic front or something like that. That could produce a line of squalls basically coming across the area. So that's kind of two ways. That's what a snow squall is. So basically, when somebody says a snow squall, and they do have snow squall warnings now, I know a lot of them issue that in the National Weather Service. Just think of a thunderstorm, but it's winter.
A thunderstorm, but it's winter. Hey, that reminds me of my topic that I kept trying to foreshadow.
Now that I stole
here.
your thunder 3-4 times, I don't know.
It's like Beetlejuice. I said thunder 3 times, and all of a sudden, lightning's gonna strike something. Anyway, so yeah, the next topic is thunder snow, and it's a pretty interesting topic. I don't know if anybody out there have you heard thunder snow?
Oh yeah,
in your lifetime?
Or
was it a garbage?
If I ever experienced thunder snow.
No, I have.
No, are you sure?
I'm pretty sure that I did. I did experience thunder sleet.
Okay, well that kind of counts.
That happened here at the office
That
one
counts.
time.
That counts. It's the same process. It's just different type of precipitation.
Yeah, it was just mixed.
It was mixed, yeah. All right. Well, one time I thought it was thunder snow, but it was just like a garbage truck coming down the street.
Plow truck or something.
Yeah, but no, I've heard thunder snow, but yeah, it's definitely it's a rare phenomenon. You don't get this in every single winter storm. It's more common in the United States, Canada, especially as Mike mentioned in snow squalls and lake effect bands where they can get pretty intense. And this is really because a lot of these storms, a lot of vertical motion, a lot of air rising, and it really causes these cloud tops to really shoot up. And really the whole thing is that you have a lot of these crystals that are really running into each other, causing a lot of these, a lot of these, static charges and
Charge separation.
Exactly. So, that's kind of what really causes a lot of these, so to speak, thunderstorms. Another way is, cold air kind of rises over warm waters. That's kind of more of a snow squally lake effect kind of aspect to that too. But one thing I guess you guys probably remember a couple years ago in December, here in Massachusetts, there was a severe thunderstorm warning, and that was a pretty intense storm. There was hail in that storm, and I know and we talked about it before in the podcast about different precipitation types, but hail versus sleet. We all know, hopefully everyone here should know what hail versus sleet is. I hope you guys know what it is.
Why don't you explain to us?
Well, I'm going to talk about sleet later.
Oh yeah, Brad's got
We
sleet.
can talk about hail if you like.
I'm stealing his thunder now. All right. Anyway, so there was hail and there was sleet. So if you imagine, if you know the difference or you don't know the difference, this was a pretty interesting storm. There was also, believe it or not, there was freezing rain in it too. So it was a really weird storm, and there was also some strong winds with it too. So it was interesting because it was I think it was in the 20s when this was going through. So yeah, anything that was falling that was liquid was essentially just a sheet of ice everywhere. There were downed trees, wires. Now that's the exception. That doesn't always happen. It's very rare to get a thunderstorm warning in December here. That's not a regular thunderstorm. But usually thunder snow in thunderstorms, they happen a lot in the Midwest, even the Rockies. A lot of these places out in Montana, like Bozeman, Montana, I found that apparently has the most instances of thunder snow in the United States, if you can believe
I
that.
wouldn't have believed that.
No,
either.
I wouldn't have guessed that one. I
No.
would have thought maybe
And-
around the Great Lakes or something.
Yeah, and it happens during the months of April and March.
Huh.
And the peak time for thunder snow is in March. But that kind of makes some sense if you think about it, because we're getting into a transitional period, so there's better chances for warmer air intrusion. So,
Right.
versus like the middle of January when it's like really cold and, you really don't have any of those warm processes to create a thunderstorm. But it's easier in the March period and April periods. And like I said, it is the United States and Canada and, Midwest, especially in the Great Lakes area where they get the lake effect snow. But it's happened in other parts of the world. In Europe, there's been instances of thunder snow. Japan, that sees a lot of snow sometimes, they see thunder snow as well. Even down in Brazil, in Rio de Janeiro, they've in just the past
Really?
year, they've and even in Germany too. Just the past year or two, there was instances of thunder snow, and it was pretty interesting because again, they don't really see that, so it's like when it's snowing, and they do get snow, and then all of a sudden you hear a rumble of thunder. It's like, was that a garbage truck like I mentioned? Was
Right.
was it a plow truck? Is it like, what's going on? Is the sky falling? But
Yeah.
yeah.
It's very muffled too, from what I have heard.
That was my next point. Yeah,
people.
it's very muffled. The acoustics, usually in a thunderstorm, you hear thunder sometimes from like 10 miles away. This really, you need to be like a mile to 3 miles away to hear it.
The snow probably acts as a buffer to
It
for one
does. It
reason.
does. It's it really keeps it muffled. And that's why whenever you don't hear like a crack of thunder.
Right.
Usually it's very
Could be an inversion going on too. A lot of times in the winter.
Exactly.
It's
So
like
it's
thunder and pillows.
Yeah.
yes, thunder and
Basically.
pillows.
I'll tell you that the most famous or most memorable thunder snow is probably everyone knows him, Jim Cantori from the Weather Channel, when he was live that one time, reporting during a snowstorm, and it was just perfect timing, and it's all over to YouTube, and
Right.
you can find it, but it's he went pretty much berserk over it. It was pretty funny to see him react like that. But yeah, I guess if you're live and you have a clap of thunder like that in the middle of a snowstorm, it would kind of get you like
What
that.
storm was that? Was that in the Chicago Groundhog Day
I
Storm?
don't know.
I know he saw it in that.
That I don't.
And that was several times, actually. That's when Chicago was having blizzard conditions. I think they had like 20 inches. And they
Yeah.
also had like 70-mile-an-hour wind gusts.
Wow.
So,
Sounds like a blizzard to me. I don't know.
yeah, I mean, I only remember it very well because I did the certified snowfall totals for that storm.
Well,
So,
that's a nice plug, Mike.
I'll, shameless plug. But that's why I remember that storm so well.
It might have been, yeah.
But I think we had enough of thunder snow. Unless you have something else, Mike, that I'm cutting you off. I don't want to.
Now I've already exhausted all my
Exhausted
electricity here, so
Let's stay on the topic of snow phenomena here and
Yeah.
oddities
Strange
with
ones.
snow. Yeah, this is something that you don't really hear too much about, but it happens actually more frequently than you think. It's just that it's very localized, and it's called industrial snow. And
So it's like industrial strength, like
Yeah.
your industrial
you
strength.
kind of get the idea,
duct tape.
but well, think of it this way: when you have warm air, okay, above real cold air, and this is the same kind of opposite setup, I guess, of a lake effect snow. But in this situation, you have like steam maybe coming off of a power plant, or anything that's hot that's being expelled into a very cold air mass, which can happen in the middle of the winter, many times. And what happens is there's just enough moisture in the air where it can rise to a certain point and then condense and fall as snow because it's cold enough. It doesn't really happen with rain. I just don't think the reaction or whatever the whole setup is. But it's more so for snow to occur. The actual definition is atmospheric particulate matter. It usually occurs at nighttime in a combination of freezing temperatures, stagnant low stratus clouds, or fog, and a temperature inversion, which we just talked about. And a temperature inversion, again, which we've covered in other podcasts, is when the temperature goes up as you go up in elevation, which is normally the opposite. Usually temperature goes down when you go up in elevation. So, again, it can happen, and you get the steam that comes off a power plant. It can rise high enough, and then it could, condense enough, and you get some snow. Not a lot of snow, but you can get enough to get a coating of snow here and there. It's just something that it's very localized. I mean, you may go outside of the power plant area or whatever the actual is what's causing it, and you have nothing. But it's just kind of a neat phenomena there. And also to go along with that is called airplane snow. Same kind of idea. And
airplane snow, what's that?
This has occurred a lot more than you think too. It's actually the
chemtrails
hot air.
Oh yeah, totally chemtrails.
It's the hot air when a plane is either taking off or landing. And all the combustion from the fuel and everything. And when it gets, again, the same kind of idea with the industrial snow, you get into a very cold air mass just above the ground, and it's just high enough to where this will condense with whatever moisture's in the air and rise just enough to fall back as snow. And it happens, quite a bit. Again, usually on the landing and takeoff patterns of certain airports. And it's been already documented just as recently as last winter. On February the 12th at Dallas-Fort Worth, both landing and takeoff, both sides had a little strip of snow that fell. It was cold enough. It was the middle of winter in Dallas. It doesn't get that cold that often there, but it was cold enough this one morning where they had a couple of little slices of snow on either side of their landing and takeoff pattern, which is kind of crazy. Outside of that, there was nothing.
Right.
Yeah, one thing I was going to bring up here is that a couple of years ago, probably like 6 or 7 years ago, shows my age, out of college, but in State College there was a
yes, there was a
remember
power
that?
plant, right?
There was it was a waste facility
Right,
treatment.
but the same idea, had steam coming up, right?
Steam, we joked around, we called it poop snow because
Yeah. I think there was actual a picture of that, and that's what somebody called it, poop snow.
Yeah, it was poop snow. But I mean, again, it was the same idea. Like
Right.
you go maybe about a mile or two away, and essentially it was clear. But then you go closer to it, and there was like an inch or 2 inches of snow. It was crazy.
Right, and then there was another
And tell your
instance-
kids, be sure not to eat that snow.
Yeah.
No, yeah.
Well, don't eat yellow snow, but
Don't
yeah,
eat yellow snow.
I guess in this situation,
Don't eat brown snow.
Oh,
Just don't eat snow. Don't eat
that's
snow.
a good question. Was it colored or was it just the same?
No, it was
sort of
it was the same. Well, you got to think about it. It wasn't. I mean, a lot of that
not
waste
poo.
A waste facility plant is cleaning the water.
I
So
was gonna say,
it's not like actual like foul.
Yeah, so we're
poop
talking
water.
about water vapor.
Yeah, water vapor.
It's
We're not
coming out.
talking about poo.
No, the
Right.
poo is not. Yeah, we just call it poo because it's a waste facility
I
treatment.
think the description on social media for that one was poop snow, I think. I have to look it
Yeah,
back up.
it
Anyway,
might have
going
been.
back to the airplane snow real quick, there was another instance in Chicago O'Hare just a couple of years ago, on November 27, 2018, and I think I remember our Midwest forecasting guru, Chris Castellano here at WeatherWorks, was actually predicting that. Or he had to go back and check the forecast, and that's why it was snowing that morning.
Wow.
Yeah, so we'll have to talk
with Chris about that.
Yeah, because
Yeah,
I
see
kind
how
of
that
remember that, because actually I think there was a certified snowfall total report done on that.
Well, that would make sense because it is falling precipitation.
Falling precipitation,
and that's what
it
we
was very
report.
localized, and yeah, it was
You know?
crazy.
That's pretty insane. And
Yeah.
I think the reason why the factory snow happens and not so much the rain,
Right.
is because you're dealing with a very cold air mass
Right.
that you're pumping this moist and humid air
It's condensing
into.
very close to the earth
Yes.
versus something else that has to
And-
go higher.
Obviously, cold air can't hold as much water as warm air.
True.
So that's why you're getting that, to condense and form flakes and all that good stuff.
Yep.
Um,
But yeah, cool phenomena about snow.
Okay. I think we'll probably take a break here. And when we come back, guys, we're going to be talking a little bit more about snow phenomenon, including the different criteria of snow, light, moderate, and heavy. And down the line, we'll be talking about pavement frost, cold air damming, and even freezing rain. So don't go away. We'll be right back after this.
Heads up, it's time to renew your subscription for certified snowfall totals. Don't get left behind with unreliable information. Get the facts with WeatherWorks. We take pride in the accuracy of our post-storm snow and ice totals and will always provide you with the weather details that matter most. Don't wait for the first winter storm. Renew now and get ahead of the pack. Visit CertifiedSnowfallTotals.com today or call us at 908-850-8600.
And welcome back to the Weather Lounge. We are talking about different precipitation types during the winter. This is our Weather Terms You Should Know podcast. And
Part two.
Part two.
And we're going to be bringing it back into the winter mode here. And I'll be talking about the different types of snow intensities. Not a whole lot to go with this, but usually, you got to wonder what makes it light snow, what makes it heavy snow. And usually it's kind of really a mixture of kind of how much snow falls over a certain period of time, and also really the visibility. And here, as meteorologists, we use that visibility to really gauge. We look at what we call Metars, and they basically they're reports from airport observations, and they tell you like, oh, it's snowing about a mile, 2 mile visibility, half a mile visibility. So
I think this is an important
Yes.
distinction, though, because, we always get people calling up and saying, like, it's snowing like crazy.
Right.
But
It's puking snow.
right. So it's like we have to have some sort of criteria of what's light, what's moderate, what's heavy.
Right.
So let's go, Mike. What do we got?
All right. Well, light snow. I mean, light snow really is kind of it could be anything. I mean, flurries technically is a light snow, but it's you're talking like basically 10-mile visibility. You could see for as far as you can. But it can get as far down as like perhaps even like a mile to 3 miles in visibility really is kind of light snow in a sense. I mean, it really depends also on the flake size too. If you notice that sometimes a heavy snow, people call it heavy snow. Really, it's if you get those big fat like dollar-sized flakes, dollar coin-sized flakes, the aggregates. There you go. That's a better word.
They're all clumping
aggregates.
together.
Yeah, they're clumped together. A lot of those, the big, the flakes that are really good for making snowmen. The wet
Snow people.
Snow people, women, men, of course, everybody. All right. Anyway, but yeah, that wet snow that's good for making anything out in the snow. But you have to really think about the actual flake size too when you're talking about that. But yeah, anything between like 1 to even 5 miles is like a more like a kind of like a lighter snow. Now you're getting into the moderate side, and that could get closer to like a mile or less. But definitely above a half mile, I would call it more like moderate snow. That's kind of my definitions that I pulled from the internet. I mean, again, it depends because we've all seen these reports coming out like it's a half mile snow. But if you look at it, it's also affected by the wind too. If you have a very windy day and you have snow, sometimes it could report the visibility is lower because the flakes are falling so fast. With the wind, it almost appears like it's
Like a snow squall sometimes when that visibility drops fast.
essentially.
Yeah.
Yes.
Well, I think too, what affects the visibility a lot of times is your fog, your freezing fog, and things like that. Because a lot of times snow will fall with freezing fog also, so that might artificially enhance or decrease your visibility.
Right.
So just something to kind of keep in mind, at least what our meteorologists keep in mind when we're looking at observations.
Exactly. And then of course heavy snow, well, it's very subjective in the world today because again, you could see a heavy snow and it's like really big flakes, but it could be falling so slowly and it could be like 3 mile visibility, and that's not really heavy snow. But heavy snow usually like a less than a half mile, usually quarter mile, half mile is usually the indication of heavy snow. But again, as Mike mentioned, really depends on sort of what the wind speeds are, if there's any fog in the mix as well. So it sounds easy on paper. Oh, it's light snow, it's moderate snow, but there's more that goes into it, and that's why it makes it a little more difficult.
Right, so we're going to get a little argument here.
Oh boy.
Because I feel that moderate snow is three quarters of a mile is still moderate snow.
Uh-huh.
And I think even half mile is a moderate snow. And then it has to get to a quarter mile before you get to heavy snow.
Technically, yes.
Aha. You see?
Technically, yes. I think less than a mile should be heavy snow.
Yeah, and again, but see, that's the thing though, because that's technically the definition. But as we mentioned, wind, fog
Right.
play a huge role in what changes visibility.
Right. Is that visibility changing because of the snow itself, or is it because of, like Mike said,
Right.
Come on,
yeah.
it's by the book, guys.
No,
By the book,
we
Mike.
can't go by the book. We're off the book. We're
It'd be
loose. We're
better
loose
if I
cannon. We're loose cannon meteorologists.
If
Come
I,
on.
if my name was Brad, then I'd say by the book Brad. That would make a lot more sense.
Yeah.
But
Yeah.
unfortunately, my name's Mike.
Me too. So this is going to make it interesting. One last thing before we jump over to, I believe our next topic is freezing rain. But before we jump into that, Brad, one more thing. So there's also another criteria. 4 inches or more of snow in 12 hours or less is considered, a heavy snow event, or 6 inches in 24 hours or less. That's another definition there. So the amount of snow that falls in a storm or in a small amount of time. So if you get like 12 inches of snow in like 5 hours, that's ridiculous. That's the rate of snow should be heavy, and it's probably a quarter mile or less for a good portion of the time. So, but that's about it. So let's move over now to Brad's topic here.
It's a lot of times it's like an inch an hour. I would say, would be heavier snow.
All right, so let's go back to where we were talking about hail earlier today in the podcast, and then we're going to go on to sleet and freezing rain. Just remember, hail comes from a thunderstorm, and again, that's going to most likely happen in the summer, with the exception of that one thing we talked about when there was a warning in Massachusetts, and I'm sure it's happened before, where you get some hail even in the wintertime from a thunderstorm. But again, 99.8% of the time that hail is going to come from a summertime thunderstorm, which of course then you can't get sleet because it's just too hot. Sleet is a wintry precipitation type, and basically it starts as a snowflake, it starts moving down through the cloud, and then there's a warm layer to where the snowflake melts and becomes liquid. However, it goes back into a cold part of the atmosphere where it's below freezing, and then it really kind of just turns into a soft piece of ice, I guess.
Yeah,
is an easy way to call it.
A little ball of ice. It almost looks like a BB or something
And
like
that's
that.
why there's confusion between hail and sleet, right? It may not bounce as much as hail does. You know when you're getting hail.
Yeah, I mean they're both pieces of ice that
Right.
come. They're just different processes
Right.
that produce the sleet and the hail. Like in the thunderstorm hail process, you're having raindrops that get lofted high up into the cloud. They freeze.
Get different layers of ice. Right.
Yep, they come down on the downdraft. They hit the updraft. They go back up again, and it keeps rhyming more ice
until they're heavy enough to fall.
Yeah, over and over until it overcomes that updraft and it falls to the ground. Usually hail is much bigger. We're talking like, dime size or
Right.
larger or something to that effect.
And the sleet's kind of, I guess we can call it almost like soft hail, if you want an easy description for folks out there. I mean, it's it doesn't hurt as much as hail, but it'll still pelt you a little bit.
Yeah, I mean, it will. I mean, especially if you have some a nor'easter and you have those
Right.
gusty winds, sleet's hitting you in the face. It doesn't feel great. It's like getting sandblasted.
And it's tough to remove sleet.
Oh.
We've
Let's not
talked about
talk
this
that.
before. We've talked about this before. It's very dense. And usually when you shovel, you're shoveling snow, it's one thing, but when you get some sleet mixed in there because it's like twice or 3 times as heavy. And those little balls of ice, if you will, they will pile up, and they're hard to melt too. They won't just kind of sit there and what's the joke we use around here at WeatherWorks? You can salt all you want with sleet because it kind of just sits there and laughs at the sleet ball.
Yeah, it kind of looks at it and says, I see you, salt.
Yeah.
I'm just a sleet ice ball. I'm sorry.
I
I'm
need a
not
lot
gonna
more
melt.
of that to get rid of me.
Yeah, I mean, and yeah, you're right. It's a lot more dense. So it's basically a 3-to-1 ratio. When you talk about snow ratios, are usually 10-to-1. So an inch of water gets you 10 inches of snow, but it's 3-to-1
Right.
For sleet. So that just shows you how much more dense.
And we've talked to a lot of our clients too when they say, I'd rather have a foot of snow, of powdery snow, versus 4 inches of sleet and snow mixed.
100%. I mean,
It's just so much easier to remove.
Yeah, it's easier to push. It doesn't, fall off the sides of your plow constantly like sleet does. And it's easier to kind of drive through too, because sleet's like, if you get enough of it, it's like driving on ball bearings.
I was gonna say, yeah.
I thought my 4-wheel drive wasn't working one time when we had a big sleet storm, because I was just like, maybe the truck guys out there would be like, what kind of truck are you driving? You driving a Ford or a Chevy? They all have their opinions,
And then, moving on to freezing rain, that's, again, we've gone over this kind of stuff before on the podcast, but it's basically, again, snow is falling well above us and well into the clouds, but there's a good area of warm air that's riding, I guess, along the middle and even the lower parts of the atmosphere where it's above freezing. So the snowflake comes down the cloud and it melts and becomes liquid. And then it stays liquid. It doesn't have that chance to get over to sleet. It falls as liquid onto the surface of the earth, which is trees or cars, mailboxes. However, at the surface here, it may be 30 degrees, 29 degrees, 28 degrees. So it basically just freezes on contact. So again, you'll be driving down the road and you'll see it's just falling rain, liquid. Oh, it's raining outside, but yet there's ice accumulating on just about every possible object and surface, around you. So that's the worst, of course, with any kind of wintry precipitation.
Yes. I mean, very dangerous. Also, it's a hazardous type of precipitation when we're talking about power outages and things like that, because you're getting all that ice rhyming on power lines and putting all that weight on the power lines. Eventually, they're going to give up and snap, or a tree branch is going to give up and snap onto the power line and cause your issues for sure.
Right. So again, rain. It's just raining down liquid, and temperatures though are below freezing at the surface. Sometimes you can get freezing rain at like 20 degrees. I mean, it's been known to happen. I mean, it's just that much warm air aloft and above you. That's making that snowflake turn into liquid rain, but it's so cold at the surface that it's just causing a mess. And this kind of goes hand in hand with my last weather term today is. It's cold air damming. And basically what happens is...
So what are you doing? Cursing the cold air? Is that what you're doing?
Well,
damn you, cold air.
We have cold air damming. We are cursing it.
No, the Simpsons thing with old man yelling.
Oh, yeah, old man yells at cloud.
Old man yells at cloud. Yeah,
but,
that's it.
It is something that happens a lot here in the Northeast because of the Appalachian Mountains. And the normal setup is a large area of high pressure over New England. And what that does is it kind of keeps the wind northeast, and it piles up the cold air and dense cold air at the surface and right up against the eastern side of the Appalachian Mountains. And it's also called a wedge. And what happens then is maybe we get a system that comes up out of the southwest, and it's going to spread precipitation across the area. And then that is what may lead to some snow first, and then it goes over to sleet, and then it goes over to freezing rain. And again, this is all because of this cold air damming, and it's hard to get rid of east of the Appalachians. I mean, a lot of times, like right along the coast, it'll start to warm up enough to where it'll go over to all rain, the precipitation. However, you get deep into, parts of Pennsylvania, upstate New York, and really west of I-95, then that cold air damming, it's tough to scour out, and it'll cause a problem with a lot of winter weather. Really any time from like November through March, it can happen around here.
Yeah, and this typically happens in your valleys, like you were talking about. I mean, that cold air is near the surface. The warm air is riding over top of that cold air locked into the valley. So it just rains, and freezing rains into that creates your ice storms. And some places that come to mind are like the Lehigh Valley. Right. In Pennsylvania, but also, thinking about northern New Jersey, I'm thinking about
Connecticut River Valley. Connecticut, that's
for sure.
Hartford and Bradley are tough to really get warm in the winter.
Yes, the Hartford area really locks in with cold air damming with a north wind. Same thing across northern portions of Massachusetts and southern portions of New Hampshire in the Merrimack Valley. Get stuck a lot of times. Especially when you have a storm, kind of one riding up the Appalachians and a secondary low developing on the coast.
And then you still have that area of high pressure over New England that's keeping the cold air in place.
And it'll just lock it in with that north wind. And models do not do a very good job. So for all of the people out there who are model watchers and things like that, that's all fine and dandy, but you got to understand your climatology of the region too, because I know that if I have that situation, those models are going to warm it up way too fast.
The strength of the cold air damming is always underdone on every model. I don't care what model you're looking at, whether it's the NAM, the HER, all the short-term models. They do not do a good job with cold air damming.
Yeah, 100%. So cold air damming, now that we cursed the cold air, it's time to talk a little bit about
Our
frost.
last weather term.
Yes.
Frost is fun.
Frost is a good time, right?
Frosty the Snowman is a fun character. So are we talking about Frosty here?
Come on, Mike. We're not talking
That was
about
one of my
Frosty.
favorite childhood holiday
Frosty the
cartoons.
Snowman?
Don't you say
Yeah.
things
That's
about
your
my
favorite,
my
I said one of
Mr.
them, one of them.
Frosty.
I gotta think about that. It's probably very close between like Rudolph and Charlie Brown
I
Christmas.
think we got another podcast topic here.
Or
Yeah.
are we talking about
Yo,
a
this-
Frosty from Wendy's?
No.
Okay.
Not talking about Wendy's.
All right. I
Frosties.
think I'm done talking here.
People
so.
dipping fries in those. I just don't understand that.
It's actually
still.
good.
I don't know about that. But anyway, but I think that's a good podcast topic. We could talk about holiday winter related movies, maybe.
I'm going to write that down.
Might be a good one. What's
Die
your
Hard is
favorites?
going to be one of those, right?
You know, that's a big like contention there.
It's a Christmas movie, so it's
People-
holiday.
I don't consider a Christmas movie. I'm sorry.
It's because it happened around
I
Christmas.
know.
It's a Christmas movie.
But
Maybe not a lot of weather involved, but it's a Christmas movie, so just
See,
wanted
I
to
don't
put
think
that out
Home
there.
Alone is a Christmas movie, and that's
What do you mean? It's during Christmas.
It's
Home
during
Alone,
Christmas.
well, it's not. Yeah, I mean, it's set around Christmas, but I don't know. I don't know if it's really a
All right,
Christmas movie.
We're getting off topic
well.
here, but
This is a topic. We're gonna have a non-weather podcast. I think soon.
We're gonna have our arguments on what is a
Yes,
Christmas
we
movie
have
and what is
to.
not.
so
a
stay,
Christmas
stay
movie.
tuned for that amazing episode.
All right, let's go
that'll
back
come
to
out.
our frosty weather term here.
Frosty, and we're not talking about the snowman. We're talking about frost, which happens on your cars and grass and things like that. So, how does that even happen? That's what we have to look at. So, what happens is that water vapor, it gets cold enough near the surface that water vapor will go straight from a vapor to ice onto the grass or your car. It's called deposition is the process that happens here. And basically that moist air, it cools enough to get to the frost point when it starts to develop that ice that you have to scrape off your car every morning if you're not in a garage, which is incredibly annoying. And I'm very happy I now have a 2-car garage at my house because I don't have to do that anymore. But yeah, so that's essentially what frost is. But some people might not know that frost doesn't only happen on grass and cars, it can also happen on the pavement itself.
Right, and that's tricky.
This is a definite tricky one and a very hazardous
Tricky to
one
see
too.
and tricky to forecast.
Yes, and basically I've actually seen this on my neighborhood road before, which was quite surprising to me. But what does happen a lot of times is generally you have to have a very cold surface. Like maybe you had a stretch of days that was in the teens or something like that. And then you have air with more moisture moving in. But
Eviction.
Yes, that's it. A moisture eviction or a dew point eviction, we like to call it. And when that happens, the air is still below freezing, but we're evecting in that moist air. And that is like, it's just going to condense on stuff like a soda bottle or something like that. And then it'll freeze because the temperatures are cold, the pavements are cold. And this situation does happen a lot of times. It's happened on Long Island before. It's happened in Connecticut before. A lot of times getting that extra moisture off the sound there, the Long Island Sound. So that's certainly a situation, and it can be very dangerous. We're getting very good at predicting this now here at WeatherWorks. We do have several clients that are more concerned about that, some of our Storm Alert clients. And it has saved our clients in the past when we have, predicted those.
Same thing with an overpass, correct?
Yeah.
Like when you get the cold air underneath.
Right. And a lot of times that can happen if you have a warm river or something like that below it and it gets very cold. The steam from the river rises up.
Yeah, that's amazing to even think about
Ice is
things
on
like
the
that.
Above
Right.
the river.
It's not a lot of ice. It's just enough to glaze it over. You
It's
barely see it,
so
but
thin.
it's
Yeah, very, very thin. But usually all it takes is a pre-treatment of de-icer. And then that usually takes
holds
care
it
of
at
things.
least for like the morning commute.
Yes.
Right.
So
Till it
that's
warms up enough.
something that we've seen a lot of our clients do and has prevented a lot of accidents and things like that if they know it's coming. But one other frost piece I should talk about is something called Horfrost.
Oh, yeah.
Now, hold on a second.
No, I promise you, we're not talking dirty here.
This is not an R-rated show.
Yes, Horfrost.
Before we get reported here, Mike, please spell that.
Hoar. Horfrost. It's a thing. Look it up. I promise you, it's a real thing, and I'm not making it up. We're not talking dirty in any way. But what Horfrost is, I'm sorry, I just can't get over the name of this. How they named it, this is just beyond me. But anyway, so a Horfrost is basically a very thick frost that's very feathery that forms on things. And this will be, if you look it up on your computer, it'll be like, an inch thick on fences and mailboxes and things like that. Sometimes it even accumulates on the road enough to provide a coating of frost, and it becomes very slippery for sure. But it certainly is a thing, and it's pretty to look at, but can be very hazardous too because there's so much of it that does form. So quite an interesting thing there with the frost. I got to say, I never saw a thick hoarfrost like that.
It derives from an Old English word that it's related to the word HOAR, but it means like old and age. So I guess because it's feathery.
And thanks for joining us here at the Weather Lounge, and we've been now cut off by the...
No, I don't think the what was it, the FCC would cut us off for this. It's a real thing, FCC. I promise. Where's
it most common?
I believe mostly out in the plain states from what I've seen, but I've seen a lot of it too even happen as far east as Tennessee, because it has coated roadways and cause some issues with some of our analysis and things of that nature. I think Mike is absolutely right. It's an Old English term that means old. So I don't know why they applied old to it. Maybe because it's just white and feathery. They think of white hair, maybe. Or something.
Maybe.
I don't know.
That could be it. Yeah. I'm looking at the time here, and we've definitely talked a lot, and I don't see anything else.
Who looks at the time?
Right? Who has time anymore? Right? But hey, guys, great episode. We talked a lot about the different types of precipitation. Like we said, there's a whole bunch of topics that we can talk about in terms of definitions, and I'm sure we'll have a part 3 and maybe a part 4. I mean, we could have as many parts as we want. We'll just have to find interesting topics that won't bore.
If you have any topics you'd like us to talk about,
of course,
let us know.
And and if you want to give us any information, you can always shoot us an email at weatherlounge@weatherworksinc.com. And thanks for listening, guys. Of course, if you like this podcast, give it a like, a review on any podcasting app you listen to. We really appreciate it, and it definitely helps out the podcast as well. And for all of us here at the Weather Lounge, I'm Michael Prianti, and we will see you here in about 2 weeks with a new episode.